You see this? A postulate is to assume or claim as true, existent, or necessary. All right, so what is a postulate about light? It is a basic postulate. It is absolutely necessary for the theory of relativity that the speed of light is constant. All right, this can be broken down into two parts. The speed of light is independent of the motion of the observer. The speed of light does not vary with time or place. That's just completely nonsense. The speed of light is very variable, and they base everything about where we are in the universe on the redshift, claiming that the speed of light is not variable. It's consistent, and that's why everything is being pulled away from us. Let me explain. Okay, as you will see, this is just nonsense. They're saying the approximate age of the universe is 13.8 billion years, and that's based on redshift. All right, well, they say everything's moving away from us because of expansion, because light can't change speeds. I showed there's no question whatsoever. Light can speed up and slow down. That's light speeding up. All right, there's no question about it. There's light slowing down. It's going fast and slowing down. Not a problem to do that. We can separate light. We can create the black and separate it from the white. The black stays on this side, the white comes through. I've shown all this, and I will show it more and more and more and more and more and more detail. Because we found exact same particles Fermilab and CERN have found, but they just have them in a pile of debris. We can see them because we used light to start with. We didn't start with huge, huge particles, which they started with things like this. We started with this. We're down here. These are the same things. Light is just light. All right, you can't get hurt from light, but you can get a lot of energy from it because electricity is half of the particle of light. Electricity is the white particles. But you got to rip that away from the black. We could do that with our venturi right here. Right there, here it is done. The white is turned into a shower. That's what they want to see. This is not my doodle here. This is from I guess Fermilab or CERN, one or the other. And they take the muon, it goes to a sterile muon, the black goes to a sterile muon. The white particle, which was attached to the black, turns into a shower. That's it right there. And for that, you can get up to trillions of electron volts, starting out with, like a zillionth of that. So there's a huge amount of electricity we should be able to get. And like I said, I showed a device right here. I think you could put enough stuff in here. But this is just a guess at this point because nobody's done it. All we've done is, and Rod did all of that stuff, so I'm not taking any credit for what he did. I take the credit for the atomic theory and so forth. This is my theory, goes back to 1970, which is dipole electron flood theory. There's nothing but dipoles. There's no just giant, big, huge positive and tiny little electron here and there. No, it just never made sense. It doesn't make sense today. But you have to follow the rules. They say, oh, this is a constant. This is a law. The speed of light is constant. To this, to that, to do. No. You look at what the evidence presents, and then you make a conclusion. This is my conclusion, that light is made of the black and the white particle, which is what they see at CERN. So it's not like it's unseen, with the glowy edge around it, which is this right here. There's just no difference whatsoever. And these can get big and small and squirt through, and the black cannot. And they say at CERN, this is a fixed particle, this is a point particle. And it's... And I am going to be going into some of what CERN had to say about these particles in a minute. I'll probably put it in this video, maybe not. It's been running a while here, so I probably won't do that. But the redshift, this isn't crazy. It's saying, as a result, objects moving towards Earth will experience a wavelength toward the blue. I show that with the moon. They're moving away from Earth to experience the redshift towards the red spectrum. If it's slowing down, it's going to go towards the red spectrum too, because it's coming in fast. Right? It's coming in like this. By the time it hits here, it's in a redshift. But the light started way out there, yes, but it just got slower and slower and slower and slower and slower. So they say, oh, it's farther and farther and farther and farther. No, it's slower and slower. And then they take the cosmic microwave radiation background, which is just nothing more than particles just laying around here, floating around, basically. Those are ones that you almost completely stop moving. So they're floating around. They give a glow to the universe. That's the cosmic microwave background. Electron flood theory solves everything. There's not a single thing it doesn't address. Not one single thing. If you can come up with one, come up with it, and I'll address it. All right, listen to this. The Doppler effect is basically what's going on here. And it says, as a result, objects moving towards the Earth will experience a wave shift towards the blue. And I'll show you this actually happening. And objects moving away from the Earth will experience a wavelength shift towards the red. And here it is. Unshifted is what the normal nature of light is supposed to be. Now, redshifted, you see these things, they move this way. Everything moved down a little bit that way. And they say that's because it's redshifted, because we're here and the light is being pulled away because we're expanding, so it's shifting towards the red. That's why we're getting down here in this range. Now, if it's hitting against you, it shifts towards the blue and it gets crunchier. More blue, or more shift this way means more blue. And I can show you this in our light experiments. That's the key. We did all the experiments. This is just not true. This is just not true at all. These are what's called the Fraunhofer lines, these dark spaces. They are true lines, and they are in these molecules and gases. Yes, I agree with that 100%. And they found, I don't know, hundreds of them, I think. And they a lot of them relate to, obviously to the periodic chart, or bouncing off these gases, oxygen, nitrogen, hydrogen, carbon, all that stuff that's in space. And we're seeing the shifted, but it's only because it's slowing down. As it comes at us, first of all, it comes real fast, and it slows down. That's what's going on. It's not red shifting because it's being pulled away. It's red shifting because it's slowing down. And let me show you. Okay, this is literally a blue laser coming in really fast and shifting red, shifting towards the red. The more it stretches out, the more red it is. All right, you see it? The more it stretches out, the more red it is. Up here it's blue. It's still blue down here too, because it's not slowed down that much, but it's shifting into the red. Now I can show the other thing happening where the moon is actually creating a blue shift, where it's crashing into the atmosphere, forcing the light to shift blue. And I can show you that right here. We got some fabulous shots here. Look at this. You see the blue shift? What's going on here? And you see all these? These are all electromagnetic fields around spinning polar particles, which are whatever they are out there, planets, or I don't know how far these things are. They have no idea, because they think the light is going the same speed and everything's being pulled away. So that's why they're billions of light years away. It's not right. These are more or less the same thing the Doppler waves. And at a certain distance, they no longer impact. But up to here, when they're down close, tight, they go, and blah, 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 blah. Now, this is, the moon doesn't spin. It just rotates around our Earth. But it's moving forward, which is causing this light to crush into the blue spectrum. So if the light is coming in just normal like this, but because it's pushing against it, yes, it's going down into the blue spectrum. So we see it as blue right there. Now here, we're seeing it just basically not accelerated or decelerated, maybe a little bit shifted to the red. You can see a little reddish tint there, because that would be the red shift. But this is definitely the blue shift. And what this is, je ne sais pas. I have some ideas, but they're like, they're just ideas. And everything I have found is crazy. So I'm no longer going to say they're crazy ideas. They're just ideas. Now, I do want to give credit to this guy, this Joshua Glatt from Utah State University. He was calculating the redshift using astronomical spectroscopy, which is the shifting, which I showed you. And the pictures I showed you are from his paper here, and this was from 2018. Now, he was just looking to see if he could calculate out the redshift. I didn't really follow too much other than to just see what I needed to see, which was what he showed. Hold on, let me show you what he showed. All right, here it is right here. This is what he showed, and it's very simple. It can't be any more simple than this. But they're trying to figure out how fast everything's moving away. And it just doesn't work. It's just the light is slowing down as it reaches us. And I show this, you can see it. There's no question that it does this. That's like sped up fast, slowing down. Undeniable. All right, I just showed you the blue coming through here, hot and slowing down. This is red accelerating. This is what a red laser, pulsed red laser looks like when it's not accelerating. The reason you can see it glowing here a little bit is because it's beginning to accelerate towards our venturi, which is down here. The reason you see all these little bright dots in here all around is those are gases in the air that get excited when this pushes them out of the way. This gets most excited because it's doing a pushing. These are shoving back. I call it push to shove. The pushers always get real glowy, and the shover backs, they get glowy and they get out of the way. So this has to push through whatever this light is coming through. When I shine a light on something, when I turn a light on something, it's got to shine through everything's in front of it. So you're going to see a little bit of a glow in the air, but not a whole lot. With this in the conditions Rod had it in, and I'm not sure whether he used water molecules or moisture or what he did here, but it's just fabulous stuff he did. And I let him loose to do it. I did some on my own, and it was anywhere near what he did. And we had another guy, Fabian Boulay, did some nice work too. But you can see, this is, like I showed you, that's just a single wave. This is acceleration. There's not a single person alive. They can't understand that. That wave was here. The particle, the particle is coming out now. And this is where it collides on itself because it's an explosion. This is literally a subatomic nuclear explosion. And I'm not kidding you. Subatomic, smaller than atoms. Nuclear, because they're all made parts of the nucleus. Explosion, because they split the black from the white here and recombine here. That's fission, that's fusion. This is a subatomic nuclear explosion. The energy created here is just exponentially enormous. From here, there was almost no energy whatsoever. Then it accelerated, then it exploded because of the tuned venturi, which only allowed the white to come through, which is to create electron showers, which is what CERN and all of them want to do. They want to do muon neutrinos attached to the electron neutrino. That's a black and a white ball. And the black to go off on its own, and the white to turn into a shower. That's it right there. And when they were attached together, they looked like this. It's like that. And before they stacked up on themselves, it looked like photons in the air. Normally, I don't think you see these in the air. You see these kind of things tops. Normally, you see this, just sort of a almost nothing glow. But this one here, this is right here in the middle of heading to the venturi. This is the one that glows. See down here, you don't really have all these glow, nothing hardly. But here, it's the blowback that creates the photons, first of all, as perfect photons. Normally, I don't think they show up like that until they bounce. They normally have like the flavored neutrinos of different flavors, and then once they hit and bounce, that's when you see them as full photons, because it's a light ball coming back at you. And it's a light ball going this way too, but I don't know. It's hard to tell. I can't really make a determination there. I'm trying to figure that out. But I know they turn into these balls as they stack up on themselves. And the same thing with the green. Here it is right here. The green's the same particle. They're all the same particle. Blue is too. Blue you really can't see very well, but you can see that it's two whites attached to something, and it slows down, and but the green and the red you can see pretty well. And of course, here's the the neutrino phases. And then this. Now, this one's getting charged up on the bottom. It's just ready to flip. You see how it's not a ball anymore? And the white does the same thing. They all flip. They charge up. The leading one charges up and flip. And then the trailing one comes in front to start accepting all the energy. And then that's called a muon wobble. They see them going, and they see them doing it. And here's what they look like in full-fledged wobbleness. You see them? And every time you see a break between them, that's a wobble. This here is the reason you see that glowing like that is because these guys are impinging on each other's fields. That's why it glows. Where they're not really pushing hard against anybody, they don't glow a whole lot. But when everybody's fields are balled together like this, now you got an issue where everybody wants to, it starts glowing. That's what that's all about. When I just said that's what that's all about, that's not really what all that that's about. I can't explain it. All I know is they don't appear to have any weight whatsoever. None. Zero. Although they're attached. Oh boy, I don't know if this is a separated particle or this is a full photon. I think these are full photons at this point. Yeah, these are full photons. I'm telling you, sometimes this can get confusing. These are full photons. You don't see the black, you just see the glowy part, but the black is going to be in between here. And I think, let me take a look at the blue. Yeah, you see it blue, like I say, you can't really even tell there's two particles there. It's coming in so fast. And it starts to slow down, slow down, slow down, slow down. And then here you can see there is two particles, and there's this black between them. Now let's look at that red again. That looks pretty similar when it's red. All right, so let me sum up what I have stated so far. I'm stating that light is made out of dipoles, and two dipoles together make a photon. And I've shown you the photons. These are photons. And we have separated the black from the white, which is fission. When you separate something from something else, it's fission. When you put it back together, it is fusion. Fusion. Fission apart, fusion back together. Did we do that? Yes, we did. And did we do it similar to what they want to do at Fermilab and CERN, but they cannot? Yes, we did. We separated them here, took the black particle and sent it off on its way as a sterile muon, and we took the electron neutrino white part and sent it into a shower. It's exactly what they want to do. And if you create electron showers, you can get up into the trillions of electron volts right here. This is what runs everything for electricity. This is everything. And you could put this in a lunchbox. And I have a little design I came up with right here. And Lawrence Livermore is doing the same thing. Well, they want to do the same thing. I don't know if they can or not. But they're talking about taking these high-energy electron showers, low-energy showers down here, and then they come up to the high energy, which I showed you. And the muons, they stay back. They can't get through. And that's what we did with ours, right there. And if we could shine it onto a photo receiver of some sort, and then just put a direct output or put it into a battery system, feed it into a grid, whatever you want. But you can make it as small as something like this. You carry it around in a little lunchbox. You have all your different outlets, anything you want. Just select whether it's AC, DC, USB, 50 cycles, 60 cycles, anywhere in the world, same device, solid state. All we're working with is light. We're not breaking the big particles. The reason you can't work with nuclear stuff is because of the size of the particles. We see light all the time. We're getting hit by these all the time. All the time. Every single second you're getting hit by zillions of these. that's okay. But when you get hit by these, that's not okay. That is not going to work for you. These are in your X-rays, gamma rays, and you know, they're nuclear decay. They're parts of nucleus that should be together. But they want to attach to something so desperately that when they get next to your tissue, they will explode into you. And all kinds of havoc is going to be reaped depending upon what the size of the particle is and how heavy it is and how fast it's going when it hits you. And, you know, and nuclear radiation just laying around on the ground it's deadly. It's throwing off chunks all the time. It's just unbelievable how many particles are in the smallest little things. You'd think, oh, there's only a few thousand particles in there. No, there's hundreds of millions of them, billions of them. And that's why they don't understand the periodic table. Hydrogen is not one big positive like this and one electron. No. It's like this. And my estimation is it's 823 dipoles. And that's what makes up everything is dipoles. And this one here is stable at 1825 or 1823, something like that. This one's going to be stable at around almost 8,000. And these are the two smallest particles, atoms that exist. You get up into here, you're going to be into millions. I haven't done all the calculations, but this has to change. And really the only thing that really has to change is atomic weights. It's not 1.008 for hydrogen. It's 1823, something like that. It would have to be figured out, but you know, they have the oxygen states and so forth. You got to account for all the ions, all the isotopes, all the half-lives, all the different. There's a bazillion different carbons, and not just one carbon, and they're all different weights by another electron, basically, something in that nature. Because these are just more and more. You add more and more and more, and you get there. Stability is when you have an exact certain amount. Let's say its stability is 2,000. You could still be down here at 1950, and it would still be that same element. It just wants to gain 50 more to get stable. And that's what they call a half-life. It starts taking on more and more and more. And you look at the isotopes of carbon. Just look up isotopes of carbon. You'll see the atomic weight just keeps going up until it hits exactly 12, and then it's stable. 13, it's pretty stable. And then 14, 15, 16, 17, it keeps going up. That's all it is. And that's the only way life can function. You can't function with these particles not being able to break up into thousands and billions of pieces. And that's what enzymes do. And they do it in a matter of a millisecond. They break down millions of of these little particles and turn them into other things to make them work for your body. That's how nucleophilic substitution and invasion works. All right, so we got a lot of thinking to do, my friends. All right, I'm sorry, I get carried away here and there, but it's all related. It's all particles. Now, I showed you light is accelerating from its not accelerate. It's just beginning to accelerate here. I showed you here where the black actually separates from the white, and I showed you here that CERN and Fermilab have seen these same particles. This is right from Fermilab. It's an article called "What's the Point?" I believe it's called, from Fermilab, and it shows this particle and this particle, and that's what we found. That's what we found. We found them, and we were able to separate them. So we did fission and fusion, and electron showers, accelerated the light, created atomic, subatomic, nuclear explosion. Literally, that's just a fact. I mean, it ain't bragging if it's true. It's true. And there it is right there. That's the explosion. Exactly identical explosion as a nuclear bomb. You hear the whistler wave, then everything burns up, nothing moves, and then boom, everything goes. And it all pulsates out from here. Now, down here, it's like extreme. They call that the Doppler effect. It's light slowing down as it moves forward through the medium. And that's what's happening in space. It's not that everything's being pulled away and stretched away. Now let's look at how light actually moves. It doesn't flap like a wave. It spins like a circle. All right, this is what happens. It spins. This is a single slit, but it's a venturi. It's a funnel, basically. Straight up and down funnel. So when this thing hits, it's got to get through that venturi. Now, sometimes it hits and goes that way. Sometimes it hits and goes this way. You see how that's like a drill bit? It's coming up over the top and then dipping down under this side, and that's dipping down under that side. It's like just like a drill bit in a drill. And you can see all of these very, very fine lines of the interference patterns. And the reason that is because these do not want to be next to each other. As they come through, they set up a very, very, a very clean pattern, depending upon how the venturi is set up. This is what is the whole deal here. If you don't have the venturi right, you're not going to get anything right. And Rod spent literally years and years doing this. And I give him all the credit for having this absolute fabulous result. I mean, it's just unbelievable. So there's no question that the particles are spinning. And the blue one shows the same thing. The blue one here shows the same thing. That's a spinning particle. And the reason it's drifting to the left like that is because it's spinning to the right. So when it takes a shot of it, it's already shifted. It's gone some this way. All right, but here it was going so fast it wasn't even drifting. So we know they're slowing down. These are other particles and the same thing. They're coming through fast, they're slowing down. That one just happens to be, for some reason, much brighter than the other ones. Okay, I showed you the green. It's the exact same particle as the red, and it has the same the same neutrinos coming until they turn into a regular photon. I showed you the red. I showed you the single wave. I showed you, whoops, I didn't show you this one. This is the green and the red coming through the same venturi at the same time. This is the green. It reconcusses way out here. That's how much more powerful it is than the red. It just pushed the red right out of the way. Now I'm going to show you something that nobody has ever seen or probably ever will see unless you do this experiment. When these particles come through the air, they're spinning according to the polarity of the Earth. So there's an upspin and a downspin, they call it. But there's no tumble spin. This is the first time you see tumble spin. I'm going to home in on it so you can see this very clearly. This is called tumble spin. And it doesn't happen except for the fact, well, it might happen but nobody would ever notice it. It would just be a glob of junk going on. Here we can tell exactly what's happening. And what is that, Roger? Well, I'm glad you asked. It's this extremely energetic particle, extremely white and blue and everything. You see it? It's already blue shifted itself and it's downshifting back to its green. And that's from the venturi. It's upshifted it. And the red, the same thing here. It's just being pushed out of the way. Look how dim it is compared to the green. And some of them got tangled up, and there's a couple little red spots up in here, but mostly, and they are nothing more than little photons. The photons have the spin to them. How fast they're spinning determines the color. Now, these are the tumblers. You see them? See them going that way? Normally, they're going to spin this way. All right. This is an anomaly, and that's because this one is pushing it, just slamming it out of the way from that green, and then the green reconcusses way out there. So you can see how much more powerful it is. It does have, other than that, it's got exactly identical same characteristics, no difference whatsoever. The particle's the same, it's just it's spinning faster. And basically, looking at it from this is the red. The red's coming in like this. The green's coming in, and it's just, and they say, oh, I'll get out of the way, and it just pushes it away. It's coming in like real fast compared to real slow. So you get one here, and another one over here, another one over here. You don't have all the bazillions of them, you just have a row of them getting knocked out of the way. It's very cool. Now, this is the reverse concussion wave. From when it slams in here, the black keeps squirting the white through the venturi, and this is where you get all these little patterns that I showed you before. And the separation zone is right about here. It turns into photons, and the explosion zone is here. This is it goes way back to here. And look at how tight these concussion waves are here. Here, you can't even see them. There's so much explosion here. They're just entangled. Here, they're starting to spread out. Now you're getting to the Doppler effect, but look at how far away you are from there. Just think of the concussion value coming out to here. It's just staggering. You see, I hope you can see that. You see those waves way out there? Look at how tight they are, just way out there. In here, they're just nothing but a pile of whiteness. Every electron is part of its neighbor, and they just don't like that. That is when you get energy. Okay, it's impossible to believe that they can't understand this. They say that protons are made of 3 quarks, 2 called up quarks, and 1 called a down quark. That's what makes up protons. Well, how did they get isotopes? How did they get all the other stuff if this is what they're made out of? You know what? Well, let me just show you isotopes of carbon. I mentioned them. Here's carbon on the periodic chart. Right? So you get 6 protons, and there's supposed to be 6 neutrons and 6 electrons. Well, look at this. This is all carbon. How do they come up with all that stuff? This is all isotopes of carbon. All right. There's only 2 of them that are very stable, or really stable, which is carbon 12 and carbon 13. 12, you have to have exactly this number. And I agree, there's going to be one exact place that there'll be just enough particles that it's stable. It doesn't want to give any up. It doesn't want to take any on. We're good to go. But if you take a few away, like this, we go up this way. All right, so this is still carbon. But it weighs 8.0. Now, we throw another one on here. It goes up to 9, and then to 10, then 11, 12 exactly. Oops, and then it's 12 with some kind of electron volt attached to it. And then this is 12 exactly. It's stable. 13 is also stable. But then it adds another one, and another one, and another one, and another one. It keeps getting bigger and bigger and bigger. And those want to shed off those so they can come back down to be stable. You want to settle in the middle and be stable. All right? And these are what's called a half-lives. You see here? Half-life. How long do they stay in this mode before they come to stability? That's what a half-life is. And these are the different types of decay and the isotopes that come after you break down that isotope. This is all nucleophilic substitution. And this happens in your body using enzymes. Enzymes break these particles into bazillion pieces and reassemble them instantaneously. And that's why life can exist. You could not exist with this number of particles. It's impossible. No way in the world. Could never happen. Okay, I just want to show you one other thing. This is asteroid Bennu, which they just came back to Earth with a sample from there. This is asteroid Psyche, and this is like turned into metal almost completely. It's smelted. This one here is loaded with minerals and metals, and this is what a heart is right here. These are the valves of the heart, and this is what a heart looks like. These have tubing and everything coming out of them, just like a heart does. You see this? This is Psyche. And this is, they're looking at it, wow, there's going to be a ton of gold on here. Well, absolutely. A lot more than a ton. But this is the valves of the heart. Now here's Psyche. Oh, that was Psyche. This is Bennu. This is the one I just went to. The same valves. It's because it's a heart. Not only that, it has this. These have tubes sticking out of them. The hearts have tubes. There's another tube down here. All right, and this is what the heart architecture, well, these are the valves. Those are the valves we just saw. And they break right off at that. The plumbing breaks right off. And you're down into the valve, and that's exactly what we see on these here. The plumbing's broken off, and we're down at the bottom. Now that's here, snap right across, but they have other tubes coming out here and there, and the same thing on both of them. They're hearts. Now, nobody can accept this because it's too much for them, but if they're educators, they should address this. One way or the other, say, well, let's take a look at this. Instead of just blocking me out of everywhere, literally in the entire world. I have almost no reach whatsoever, and I have all the evidence. They have no evidence and all the reach. And all of it is they are in search of funding at this point. You can't deny the things I'm showing. Nobody can deny them. All they can do is dismiss them and hide from them. And don't forget, they're estimating the age of the universe based on the redshift. I showed you the redshift is absolute, total, complete nonsense, and nobody can deny it. It cannot be denied. It's just supposed to be independent of all these things. Like, it's a constant, never changes, doesn't matter what you do to it. No, it's not that at all. It slows down according to what it has to plow through. And in this case, we accelerated it. But normally it's going to slow down as it plows through, which is this one here. So, they should, the problem is they ignore this stuff because and it's hurting us. We should be able to get free energy. I'm telling you, it's not a good situation. Academic fraud. A deliberate effort to deceive includes fabrication, plagiarism, misrepresentation of historical sources, tampering with evidence, selective suppression of unwanted or unacceptable results. They want only what they will accept. And if it's unwanted, it's suppressed. That's academic fraud. And theft of ideas. That's happened to me quite as well. And of course, there's the age of the universe. What else we got here? Oh, I'm going to be getting into the Crookes radiometer. I got one here. This is going to be fun. I'm going to show how this works. And then nobody's known how this works over 150 years. They still don't know. What do I got here? Oh, yeah, this is... Well, here's what... I'll just give you this and I'm going to get off this case. A Crookes radiometer is known as a light mill. It consists of a low-pressure glass bulb. Very, very low pressure. So they've almost made it into a vacuum. But it has to have some gas in there. Now, the bulb containing a set of vanes, all right, the black and white vanes, mounted on a very, very low friction pin, a very pinned spindle. Each vane coated a black side and a white side. The vanes rotate when exposed to light, the faster rotation for more intensive light. Now, what about lasers? What about the different colors of lasers? What about regular white light? And what about heat? And what about cold? And all of those things have a similar effect. Heat will make this thing go. You don't have to have it at light. Heat will make it spin. Cold will make it spin backwards. I explained that one to me, Lucy. This is tricky, and nobody's been able to explain it. 150 years, they still have no idea because they don't understand dipole electron flood theory. So the next video is going to be on this. It's going to be fun. Stick around, my friends. I love you all, and I'm going to have a great time doing this. I got all my little toys out, and I'm ready to go. Now, the reason I had this tab open is I've been going after the big universities for fraud, which is academic fraud, involves a deliberate effort to deceive and includes all these different things: plagiarism, fabrication, misrepresentation, tampering with evidence, or, in my case, selective suppression of unwanted or unacceptable results. Why is my results unacceptable and unwanted? It doesn't have enough money attached to it. All of these things have been solved with electron flood theory. You can't walk around in circles and collect money. And they say, oh, well, we need another $150 million. Maybe we can figure this out. No, it's all done. It was done long ago and denied because they can't continue to suck the juice out of us all with taxes and federal funding and grants. And that's what's happened right now. The university system is not working. Peer review is racketeering. And the Ivy League has become the Ivy Slave League. And they've enslaved our kids. Because if you don't go there to get your degree, nobody will hire you. Because they say, oh, you're not educated. And I don't see that at all. I mean, I sent my kids to college. I paid but I knew it was just a sham. Except they went for specific, basically trades. So if you go for a specific thing, accounting or something like that, that's a whole different story. But if you go in and they say, okay, you have to take all these other courses, or we can't let you be educated because you didn't take geology and archaeology, paleontology, and all this stuff. I think this might be a little deceptive. I'm not sure. I tried contacting these people, but it's Eurofins, and it says a first look at Bennu. I've already made my predictions of what's in there, and it's going to be blood. And I already gave them all the chemistry of plasma, serum, and whole blood. And that's what they have to do, is figure out which one they got it out of, because it's going to be all those different areas are on Bennu, as I showed you before. Now, on September 24th, capsule containing the sample returned and landed back on Earth. Now, they say, of course, the next question is, what is in the sample? This is where material analysis plays a major role. It's cool to know some of the analytical techniques available at EAG, such as scanning electron microscopy, X-ray diffraction, are being used to analyze a sample from space. How awesome is that? Now, I think they're just saying that's the kind of stuff they're using, and I don't think they're the ones that are actually doing it, but it sounds like they're making it sound like they're the ones that are doing it. But it says, there's a little deeper in here, if you read it, says, here it is. After the initial studies, it was discovered Bennu's sample did contain carbon and water. Another article stated, within the first 2 weeks, scientists performed quick look analysis of the initial material, collecting images from a scanning electron microscope, infrared measurements, X-ray diffraction, chemical element analysis, X-ray computer tomography, and they used to produce a 3D model of the particles, of one of the particles, highlighting its diverse interior. And I'm going to tell you right now, I know what it is. And it's right up here somewhere. Boom. The metallic profile of blood. This will take a while to come up because it's sort of an obscure site. And here it is right here. This is what they're going to find. In addition, these are the special particles they were looking for, which is all what's in blood. And in addition to that, they're going to find a ton of iron and carbon. And these are the other metals. And here it is right here. This is whole blood. And these are going to be the concentrations and the types. That's whole blood. Here's the plasma. Same thing. What is it? What's the ratios and so forth? And here's the last one is serum. Same thing. Now, why do I say you need all three of those? Because there's 3 different spots to look at. You see here? They landed in one of these somewhere. So one of them is going to have the used blood, and one of them is going to have lymph, and one of them is going to have artery, and so we need to know which one it is. Or actually, the analysis of the blood, which is the sample they brought back, will tell us where they landed. Because they're different. They're different chemical makeup of the blood. So it's going to have different concentrations used versus the whole blood versus just a serum. Now, this is, we paid for this. We paid for them to go out to do this. It was hundreds of millions of dollars, I think. Well, yes, I'm certain it was. And they have already done this test. I want to know what's in that test. I should be able to get access to that. I haven't been able to find anybody that can give me any help. Nobody will respond whatsoever. So if you can find out what's in these samples, I'd love to know. They did, it's been 4 months they had that stuff back here. They want to study it for another 10 years. They're talking about being able to study it for 10 more years, I saw somewhere. This is just nothing but milking a cow until the cow has been dead for years and years. It's insane. And that's all it is science in search of funding. That's all that matters anymore, is get funded. I know everybody's got to make a living, but this is not the way to do it on the backs of kids and of the population. Everybody else has to pay for these guys to get in. They get paid pretty well to walk around in circles. It's just not right. And I've been, I'm not going to let loose on this. Somebody's going to have to step up, and I don't know how they're going to straighten it out other than come to my school, which is Mudfossil University. Mudfossil's all one word. And, I don't charge you anything. And basically all it is looking at all kinds of things that are perplexing right now that have no explanations. And once you find out the things that I'm showing, all of the things that I show are the explanations of everything. And our history, and maybe our eternity, all of that stuff. This is no joke. And it's being dismissed by the ones we trusted for education. It's not a good situation, my friends. I love you all and hope we can get out of this somehow and straighten this thing out. Because right now they're in control, and if the kids stand up or if the teachers stand up, they destroy them. They just keep rolling down the road the same way they do it. And it doesn't matter if they're right or wrong, they're in control. That's just bottom line. All right, I love you all. Bye.